And we took a very typical, office building, and we compared, the structure that would be concrete versus steel versus mass timber. And even after applying some of the worst case scenarios for slash management using our tool, when we add those values to the overall LCA, what we found was that mass timber still comes out a winner.
What if your sustainable mass timber project was missing a huge part of the carbon story and nobody told you? Today's guest, Varun Kohli, is a sustainability-driven architect helping design teams see the full picture of carbon in mass timber. With global firm Corgan, he helped launch the Mass Timber Carbon Calculator. It's a free tool that's changing how architects, engineers, and developers evaluate timber's true impact. And here's the twist. Only about 35% of a tree makes it into the building. The rest, the bark, the branches, the roots, it's often left behind or burned, releasing carbon that's rarely tracked in typical LCA models. But that carbon matters. And this episode isn't about knocking timber, it's about building smarter. In it, we cover where biogenic carbon hides in the supply chain, how to use this calculator to ask better questions, source smarter, and avoid greenwashing, and how to make a stronger case to owners, developers, and ESG-focused teams. If you care about doing better work and making a rock-solid sustainability case, this episode will give you sharper tools and a fresh lens. But before we dive in, early bird pricing for the Mass Timber Group Summit is ending soon. If you want to be in the room where the real mass timber conversations are happening, this is your moment. If you're an architect, an engineer, a GC, or a developer who's tired of those surface level interactions and you want to get inside the smartest rooms in the industry, this is your shot. You get to meet experts like Varun, get hands-on with the latest tools, and connect with the teams actually pushing the industry forward, and not just talking about it. And since you're a podcast listener, you get the hookup. Use code PODCAST, all caps, at masstimber.group to save $50 off your ticket. And don't wait, because these tickets are moving fast, early bird pricing ends soon, and it will sell out. So with that, let's get into it.
My name is Varun Kohli. I'm the Director of Sustainability at Corgan. Corgan's an international design practice. We have about 19 offices nationally and internationally. Employees are almost 1,200 at this point. We do all kinds of architecture and design services around aviation, data centers, education, healthcare, commercial buildings, government facilities, multifamily, you name it. So we have a fairly large practice, and I joined Corgan about 2 years ago and started the Corgan Echo group, which is really a subject matter experts group around sustainability.
And so with your background working across different firms, with Corgan working on kind of like every different building typology in there, where does the sustainability aspect come in, and like where do you plug into that?
So throughout my practice, I started as a traditional architect and worked for a number of years as just standard architecture work, and then I went off to grad school to study sustainable design, and I think one thing that opened up during that year in London when I was studying at the Architectural Association was how sustainability is essentially tied back to simple building physics, right? Understanding how buildings function with or without building systems. That was really key, and it was a kind of an eye opener. And since then, I have really strived in every position that I've had in different firms to try and integrate sustainability with design because a well-designed building is sustainable. It's in harmony with external environment. It's in harmony with what we need to create internally. So that's really been sort of the crux of what I've been trying to do for the last 20 plus years.
Got it. So it's like it's going back to, like you said, a well-designed building is sustainable, and so it's like bringing all of those kind of practices wrap around into each individual project. One of the reason that we're talking is kind of like in the mass timber space specifically, and a lot of people measure sustainability, maybe not necessarily like that holistic fundamental approach like you just talked about. It's like how much carbon is in the materials, and then there's lots of debate about how sustainable, how much carbon storing is in specific materials. is it better than one material or the other? And one of the big challenges or challenges to mass timber specifically is, hey, we might be overestimating or portraying the wrong level of carbon emissions associated with this product. Can you unpack kind of that, how we got to this point in the conversation?
Yeah. So, I mean, we at Corbin have worked with mass timber in some of our projects, and we've spent an enormous amount of time researching and around mass timber and different applications, whether it's, commercial buildings or aviation or even data centers. Um, while we were doing the first round of our research a couple of years ago, there was a report that was published by WRI, which I'm sure many of your listeners might be aware of. And that report basically pointed out the fact that our industry might have been ignoring a portion of the embodied carbon or carbon emissions calculations, mostly associated with the forestry practices. And so that triggered this question amongst our team as to, what exactly are we, what is the WII report talking about? And wanted to kind of get deeper into that question. So we looked at that report, we understood what was being said, and really came down to the point and identified a few different points in the life cycle assessment and zoomed into the slash management practice. Like that was the key. And slash, just so that you and your viewers understand, the slash is essentially the parts of the tree that are left back in the forest, right? The branches, the roots, the bark. And there are different practices for different reasons of how that slash is managed. Sometimes it's left on the forest floor, sometimes it's burned, sometimes it's masticated. And all of those different management practices have a different impact on the re-release of the biogenic carbon. Um, and maybe I need to step back a little bit and just say, the biogenic carbon is the carbon that a living organ or organism kind of sequesters over its life. So you can imagine a tree, sequestering carbon over its entire life and then being re-released back into the atmosphere. So that's a piece of carbon that gets re-released and doesn't always get equated into the calculations that we do. And so that was the premise of why we started looking at biogenic carbon and really found a way to calculate that so that we can be better informed, at least have the right questions to ask of from the project team when designers get involved.
And when you guys dove into that research, did you guys identify any like percentages of like how much of that carbon is involved in the slash versus how much ends up in the lumber, which is into the panels, columns, beams, etc.?
Yes. I mean, just that slash portion, I think overall it's assumed that roughly 35% of that tree never makes it to the final product of mass timber, right? Now there are different practices. There might be byproducts that are used for manufacturing other products, uh, which is great. I think um, what we realized was the reason we focus on slash, in essence, was that was almost the biggest chunk of that 35%. I think it was somewhere around 20-25% of the overall tree. And so that's why we focus on that and try to understand, again, with those slash management practices. And there's nothing that we have invented here, right? Like all of this information was out there. We just kind of pulled it all together and said, okay, there's a way to calculate how much biogenic carbon gets released when you burn it or you leave it in the forest. And once you do that, that becomes this added value of biogenic carbon emitted that we can plug into the overall LCA analysis of a project. And what it does then is just gets us more closer to reality of the actual embodied carbon. And this by no means is the end tool, right? Like there's more work to be done, but I think it's a good starting point for us to even understand, um, if not quantitatively, qualitatively, what is the impact?
Got it. And so you took all that information, you did the research, and then you synthesized that basically into a tool that designers and other project build team members can actually use to see where that carbon is captured versus emitted, et cetera, in the process. Can you walk us through kind of the
Yeah,
development of that tool and what it's designed to do?
absolutely. When we started, the intent was, okay, we're going to study this, we're going to understand what it is, and we'll write a white paper. And then as we were getting and writing our white paper around this topic, somebody in the team came up and like, well, we can actually build a little tool out of this, and people can calculate. So it was really, really exciting. And what that tool does is there's really two major sections of the tool. Um, the first one is dealing with the slash management and the biogenic carbon value. That part of the tool, you go in, you can pick the size of your building, estimate, of course, the square footage, the number of floors, and tell the tool whether you're using both beams and columns and flooring for mass timber, or is it just one component. You can also select the wood species or the tree species that are going to be used for each of those components. That is another variable that we often ignore because that has an impact. And then if you know what slash management practices will be, you can pick whether, if we're picking a Southern pine, do you think the practice will be burning on site, or is it going to be mastication? And based on all of those variables, we can calculate the actual metric ton CO2 E value. Um, I say actual, it's close to reality, but it's still an estimation. But we get to that value, and then you can then take that number, like I said before, you can bring it to your overall LCA, and adjust your A1 stage of the LCA analysis with this additional biogenic carbon. Now, the second stage of this tool is where you can pick which forest you're bringing the wood from, and you can almost pick like specific suppliers, and also assign your project location. And that's really the A4 transportation calculation that it does. And again, this is not something that's new in our industry, but putting it all together, you can actually begin to see the impact of transportation, picking the location, picking the wood species. That's what we're really after, is trying to get designers to understand the nuances and the differences, and how every variable impacts your embodied carbon.
So I'm going to share my screen here and I did a little mock-up while you were talking. So like a 50,000 square foot building, 5 floors, used Doug fir for columns and beams, and then SPF for the flooring, just assuming everything was side composted, and then plop this building in Denver supplied by SmartLamp. So if I'm looking at this right here, so in the top, we've got our building dimensions, total square footage, etc. Walk me through so the industry biogenic carbon, this top gray box right here. Reiterate
And so,
what part that is.
yeah. So the industry biogenic carbon is the value that you would get from a typical EPD, right? And that is by defining where the boundaries are between, A1 through A4 cycle stages. So, for example, what you get out of EPD will typically not include the forest level biogenic carbon. That carbon life cycle is typically excluded from the in the EPDs, and that's designed as per ISO standards. So it's this industry standard. What we're saying is, let's not ignore that. Let's include that calculation. So when you do that, you end up with that bottom left, left leaning. Left is always in some ways positive, right? Like
Yep.
it still has avoided carbon. And so that yellow box is where you end up after accounting for the biogenic carbon.
Got it. And so basically it's like, here's what an EPD might show you because they start measuring at the factory. If we go back to the forest, here's the other things that we would like to incorporate. And then the bottom solid yellow is like, here's where you still net out. And so if we're using, so I'm anticipating some guest objections, etc. So this is not designed to say, oh, mass timber is not as good as you think it is. Because if you're comparing it to, say, concrete or steel for the same building, all of those numbers are going to be to the right. Is correct in that assumption?
You're absolutely right. So what we did was, beyond this, we tested this out ourselves internally, and we took a very typical, office building, and we compared, the structure that would be concrete versus steel versus mass timber. And even after applying some of the worst case scenarios for slash management using our tool, when we add those values to the overall LCA, what we found was that mass timber still comes out a winner when it's for embodied carbon. So it's still a much better product. It's just that we're now accounting for some of those additional biogenic carbon that was not accounted for before. And the other thing I just want to keep emphasizing is that it's not all, it's not all the same, right? It depends on, again, the wood species, where's your project, how much is being transported, and those details are really important because that changes the value significantly.
And so I'm going to reshare that calculator again. And so what you're talking about down here is like this A4, right? So if I'm
Right.
selecting, let's say, a material supplier that is 735 miles from the project location versus 1200, we can toggle between the two and see how that changes what actually goes into the overall counts. Is that a fair assumption?
Yeah.
So if you're going, by basically choosing a supplier that's close to half the distance away from the other, like you're looking at basically a 600,000 metric ton difference, right? And that's primarily from
Yeah.
just shipping, right? Things on trucks, on trains,
Definitely.
etc. Yeah, yeah. And I think that's something that's really important. And Denver is a terrible example for me to use that, but I'm familiar with the area. That's why I use it, because there's no suppliers kind of like really close to it. But if we switched over to something on let's call it the West Coast. So where are we at
Mhm.
here? Do we have Portland on here? Yeah, we do. Okay, so if we have Portland, right, and I know Frères and Timber Lab are in there, uh, you can see same building, way different,
There you go.
very way different emission standards based on trucking that thing all the way across the country. Um, yeah, that's very interesting. So, and I think that's something that's really important, because a lot of times especially if the carbon, the ESG, the sustainability aspect is really important to the developer owner, you might be able to get, again, going back to Denver, you're shipping it from wherever. Some are farther than others, but even a 500-mile difference makes a huge dent in that emission stuff. And I'm
Exactly.
curious to see how that would weigh in practice on X producer can get it to me X% cheaper. And so if we're talking to AEC team members who are talking to their developer clients, how can they use this tool in those conversations?
So I think it starts with sort of the designers envisioning, right? Like, and do you envision a hardwood coming out of Pacific Northwest versus pine, southern pine from Southwest United States? So if designers can look at this tool and at least understand that the magnitude of difference that you were just kind of explaining, that makes a huge difference. And if we start off on the right foot, I bet that not only are you saving in transportation carbon credit of carbon emissions uh, by transporting it across the country, but you might also be saving cost, right? If you're transporting it closer to where the project is. So I think it kind of it feels like a win-win situation. It's just the fact that often we don't, we as designers, either we don't ask those questions, or we're not taking this, the carbon emissions into account. And what we're trying to do is, make it so visual and easy for you to kind of assess that from day one, when you're thinking about mass timber, you go through this tool and say, okay, it's pretty evident to me that if I'm going to be doing something in Denver, that this is where I need to be sourcing my wood. And let's just make that clear to our client. And then, off we go into the design process. So it's really trying to help our designers ask the right questions, understand really the impact of every little decision that we make.
Yeah, and going back to like, hey, maybe we're regionally or locally sourcing the wood. As a part of that calculator in the different tab, you actually have like a whole map of the United States about where these tree species are. So somebody's like, I don't have to guess. Hey, if I'm in Atlanta and I'm trying to use SPF, well, actually, did you just look at the map and there's southern yellow pine literally out your back door, right? And so people can go in there and look at that. That's something that I really like, because it's also very interesting to, just because something is local to the to the build doesn't necessarily mean it meets what you guys need structurally, right? So like different species have different
Properties. Yeah.
mechanical properties, right? It's like, hey, you might need to use a Doug fir beam for XYZ span application. You might not be able to use another species. And so like I like how you can go through with the columns and the beams and specify that different wood. Sure, everything could theoretically be the same, but you might need to mix and match some species there, and you can kind of plug and play where it's going, or excuse me, coming from.
Yeah.
Uh,
No, I think, I've always taken the approach in design, and like I said, I was talking about building physics before, but if we don't get deeper into understanding the environments that we create or the materials that we use, then we're kind of doing things maybe not so correctly, right? So the deeper we understand, the more we understand it, and the more we can make it easier for all of us to understand it, the more successful we're all going to be.
for sure. Uh, Circling back a little bit to a little bit more of those conversations again in a previous interview, so we're talking about mass timber buildings. Generally, when people are opting for mass timber, there's a couple different buckets that they're weighing. Like one is a sustainability bucket, certainly. The other is speed. The other is benefits to the owner or the occupant, whether that's leasing, employee health, productivity, etc. In that interview that I watched with you, you forgive me if I misquote, but it's basically like sometimes when you're having a conversation about a quote sustainable building, you don't even use that term. Can you unpack that for me and like maybe how other designers could utilize that in their conversations?
Uh, yeah, I think it comes from a little bit of experience that I've had in doing sustainability work for the last 25 years or so. Um, I think it's really important to understand that sustainability in itself is really what we're trying to do is to create better products and better buildings. And I no longer go in with the presumption of what sustainability means to a particular project or a client. It's more important to ask the question of the client, say, what is your target? What are you trying to do? If it's a commercial building, obviously you're trying to lease it out as quickly as possible or be prepared for those downturns where, your building is still marketable and, more than the building next door. So a lot of the stuff that we do when you have a better performing building, whether it's the energy loads that are down or we have created a much better space in terms of natural light accessibility within the space, it just becomes a better product for the client. So, when we're talking to school buildings, for example, operational cost is important. So it's not about sustainability. It's just making sure that we design such an efficient building that their month to month operational costs are not as high, or making sure that the children in the classroom do get ample natural light. We know that scientific studies have showed how well kids perform when when they have natural light versus artificial light. So those are just simple facts and they don't cost anything, right? A lot of these things are, if we understand the how things work in building, whether it's building physics or even material application, we know the benefits of it and we can show that in alignment with clients and goals. So it's less about just, sustainability as it's understood and more about just a better design and a better product.
Yeah, I completely understand that. One of the things or the trends that are kind of happening, and it's happening at different paces and different places, but there's regulations or policies that's coming out, whether they're federal, state, provincial, local, etc., about the carbon. Certainly on the operational side, that's been happening for a while, but on the embodied side, which is generally where mass timber is going to play into it, those regulations are coming. Like if you look at California, Denver, a couple other big metros are like, hey, your building embodied carbon needs to meet X threshold. Do you think that this tool can kind of help the developer owners, the clients, et cetera, kind of understand and figure out how their building is going to fit into that without having to get, 100 hours with the design team deep?
Yeah. No, absolutely. And you're absolutely right. I mean, we're hearing about that, coming in New York. I was just talking to our team member in London, and UK is kind of gearing up towards something like that as well. So it is going to show up. And yes, I hope that our tool will help. And I think the way it helps is setting people off on the right path, right? because there's plenty of tools that exist and that get into, and ours is a little bit unique because it's talking about specifically biogenic carbon. But any tool um, similar to what we have that allows designers from day one to just kind of go in and play around and say, okay, I understand how my decision will impact, biogenic carbon or embodied carbon as a whole. That just helps them kind of start at the right direction, right? I always say if you don't put your first foot forward correctly, then you're just kind of fixing that right along the design process. So if you do it right the first step, then things become just easier. So that when you come to your DD stage or something, you run an actual LCA study, you will find that you're already ahead of the game because you've kind of studied this and looked at it in advance. So any tools that we can create, and I hope that this is not just, this is just a starting of what we're trying to build, but anything that we can create and sort of socialize in our industry that helps designers on day one, just kind of coming, even without a design, you can come in and play around with this tool and understand, okay, I've got to ask these questions. I need to make sure that I'm picking the right wood species. That in itself is a huge impact.
Yeah, I like that a lot. And so what's next for this iteration of the tool? Do you guys have plans to add features? I mean, where are you guys going, maybe with the firm?
I don't think we know where we're going yet. It just came out, we just kind of released it. We're quite happy with what it is, and I think I've got some feedback from other industry partners, and so far it's been mostly very, very positive about what we're trying to do. There's a lot of questions around, how does this expand, and how does maybe, and not only, expand within what we do. I mean, I know and we know that this is not something that we can do alone, and that's why we put it out, as an open tool for our industry. And if there's partners who come in and somebody else is working on another tool that we can collaborate and expand on this, would be more than willing and happy. I think the intent is really that we are honest, that we share what we know, and at the end of the day, I still want to go back to my original thought of like, integrating sustainability and design. So these tools should help designers kind of free up and say, okay, I understand exactly what mass timber, what questions I need to ask. I can now focus on the design excellence of this project, right? And that's where we really want to be.
Yeah, I love that a lot, especially the communication aspect and collaboration, right? Because can't
Yeah.
can't do these big things in silos, right? I mean, if we're talking about like, you know, much smaller scale, but like passive house type stuff, it's like it wasn't one person that built one passive house, had it
Mhm.
perfect the first time, and then the industry just exploded with it. It's like, no, there's hundreds, if not thousands of people iterating, improving, taking feedback. And I really liked how you said, hey, we're open to, hey,
Yeah.
how can we improve? We're being transparent. We're not hiding anything behind the curtain. And so I think that's what it takes to really push these kind of initiatives forward. So I applaud you guys for taking that approach.
Thank you. Thank you.
So before I ask my last question, how can people learn more about you, learn about connect and use the tool, etc.?
Um, So yeah, go to our website, corgan.com. There's a lot of information there about myself and our team and what we're doing. And for specifically for the tool, it's corgan.com/empty carbon calculator. Um, I would love for everyone, all of your listeners, to try it out, give us feedback and any comments, and we'll be more than happy to kind of interact with folks who are trying it out.
All right. We'll link all that down below so everybody listening can click on there and check it out and then give you some feedback or give you some comments. Uh, Last question for you. If you had to tell somebody about the conversation that we just had, you had them in an elevator for 30 seconds. What are you telling them about the tool, why they should use it, and how it's going to help them?
I always kind of go back to, and I'm assuming the other person in the elevator is an architect, but um, I always go back to what Louis Kahn used to say, right? This was a famous quote: "What does a brick want to be?" Right? And if you don't understand the way I take away, what I take away from that is if you don't understand the material and its properties, you wouldn't be able to design the perfect thing that that brick wants to be. And I think we're just kind of taking that to the next level, right? Really understanding not just the material that we put in our buildings, but the bigger impact of the materials that we use. And what we're trying to do with that tool is really creating a more simple path for designers to find that answer and go on with their designing, right? And the more we can provide this information and knowledge in a simplistic way, the better projects we'll be able to design.
Yeah, I love that. Well, thanks for spending some time with me, Varun. I will look forward to seeing the next iterations and connecting more after this. And yes, everybody, please go check out Corgan's website.